Hello, my name is Brandon Burdett, and this is my physics lab for bar magnets. So for this experiment, we were tasked with finding the magnetometer on a phone and then using it to measure the magnetic field of a bar magnet at various distances away. And then for the coding in this lab, I was tasked with creating a computational model showing the magnetic field from this bar magnet. And the purpose of this is to learn more about magnetic fields. So a quick preview of the results. The top shows my magnetic fields, and that's the left, and the right shows the magnetic field at a distance d. And the bottom part shows what was actually calculated without using the coding model. So in this case, the system is the bar magnet, and the surroundings were both the Earth and any nearby objects. Here are a couple relevant physics formulas used in this lab, with the left one being the magnetic field of a dipole, and the right being the distance dependence formula. Now, in our experiment, it looked a little bit like this, with the thing on the left being the bar magnet, and then a couple meter sticks, and this way we were able to find where the magnetometer was within the phone, and then once we found out where it was, we marked it with tape, and then we moved the phone both parallel and perpendicularly to the magnet, and then we found some magnetic field numbers at these distances. Now we put these results into an Excel file, which is all of this. So on the left side, top left, we can see the different distances and the different magnetic fields measured at these distances. And then the natural log of these values was then put into the graph seen on the right. And then at the bottom, you can see the distances, and what's really important is the far right, the net magnetic field, which will be compared to the computational model eventually in this lab. Now I'm going to show you guys my glow script model. Some of the initial conditions needed for this lab are a constant here at the top. Then I created the magnet at the origin for this model, and then I also needed to include the magnetic moment, or mu, which I calculated. Now, using that first formula I showed you guys earlier, here is my function where I'm creating the magnetic field, and then I'll use this a bunch later as I create my magnetic fields at different spots. So at the top, I'm creating the various different observation locations that we measured the magnetic fields at. And then here at the bottom, I'm creating a couple arrows which show the magnetic field on axis of the bar magnet, using that function I just showed you last slide. Now on the left side, you can see I'm creating the magnetic field functions using that same function at the different perpendicular to the magnet locations. And then here on the right side, I am creating the magnetic field at a 45-degree angle from the bar magnet. Now here are the results with the bar magnet seen in the middle. Then you can see all the different magnetic field vectors pointing at different distances away. And then you can also see the numbers for these on the right side. Now here's a comparison of these two models, and they are slightly off, but you can see that they are relatively close, meaning most of what I was doing was correct in both the calculations in the experiment and the computational model. Now there's a few reasons for this discrepancy, one being nearby items could have a magnetic field which skew the results, and then also we could have not found the exact location of the magnetometer, which will make it slightly off. And then I also could have messed up something small in my coding or in my calculations. There's always room for error there. Now here's another reason where you could go wrong on this lab, where if you don't compensate for the magnetic north and just lay out your meter stick anywhere, your results are definitely going to be inaccurate, since the magnetic field from the Earth is going to have a pretty heavy effect on what your recording. Now, if I were to use two end-to-end of the same magnets and then did this exact same experiment, the results would be similar. The direction of the magnetic field would be the same, but the magnitude would be double since there are two of these magnets. Thank you for listening to my lab 4 about bar magnets.